Hello and welcome back. So in these lecture notes, we're going to talk about inheritance. So inheritance is a system by which we can define new classes that inherit many of the properties of already existing classes. Inheritance is a really useful thing to do when we have a problem that is almost solved by an existing class, but not quite. So we have an existing class that comes really close to doing what we want to do, but we need to extend it or change it in a relatively small way in order to completely solve our problem. So let's do an example. Suppose that I want to use Python to keep track of my grocery shopping. So suppose my grocery pantry is represented by a dict. So here's my pantry. My pantry has rice in it, measured in pounds, and there are 2 pounds of rice in my pantry. It has harissa measured in jars, and there's just one of those. It has onions, and there are 5 of those, and lemons, and there are 3 of those. Okay, so that's what's in my pantry. Okay, so now suppose that I go shopping. So I go to the grocery store and I come back with the contents of my shopping trip, which I'll represent by another dict. Rice in pounds. I bought 1 more pound of rice. Onions, I bought 2 more onions. And spinach, that's new. I bought 1 pound of spinach. Okay, so what I'd like to do is update my pantry with the contents of my shopping trip. However, this is most naturally represented as addition. I'd like to add these dictionaries together in such a way that the result will say that, yeah, I have 3 pounds of rice because I started with 2 and I bought 1. I have 1 pound of harissa because I started with 1 and bought none. I have 7 onions because I started with 5 and bought 2, and so on. So the question now is, how can I add these 2 dictionaries together to create a new dictionary? So of course, I could find a way to do this with a for loop, but I'd like to do a more elegant and reusable solution. And for this, inheritance is really useful. So what we're going to do is we're going to define a new class that inherits from the dictionary class and which supports addition. So in particular, once we're done implementing this class, we'll be able to write a pantry plus equals shopping trip, just like we would with any other integer addition, for example, in order to represent the operation of adding new groceries to our pantry. So that's the game. We are going to define a new class that inherits from dict in order to achieve a nice, clean result. So how does the syntax work? So the first thing we can do here is check out the syntax, and the syntax is very simple. So I'm going to call my new class arithmetic dict, and I'm going to pass inside the parentheses here class arithmetic dict of dict, and then I'm just going to pass. So far in this class, nothing happens, except for the arithmetic dict inheriting from dict. Now, this is already both kind of boring and kind of exciting at the same time. So what's boring here is that my new class doesn't do anything that dict doesn't already do. What's exciting is that my new class does everything that dict does. In fact, it's essentially already a dict. So let's take a look at that. So here's x. And I'm going to say that x is an arithmetic dict, and I'm going to initialize it with a dictionary argument. So a corresponds to 1 and b corresponds to 2, say. So here's an example of an arithmetic dict. And then if I check what x is, so I can see that x is actually looks like a dict when I ask Python to show it to me. I can check the type of x. The type of x is an arithmetic dict, so it's not actually a dict, it's an arithmetic dict, but that's fine. And then I have this additional new function called isInstance. So that's a new function that I'm introducing right now. So if I check isInstance called on x and dict, what this does is it asks Python true or false, is x an instance of the dict class? And the answer is yes, true. X is an instance of the dict class. So not only is X an instance of arithmetic dict, it's also an instance of dict. And that's because arithmetic dict inherits from dict. Anything that is of class arithmetic dict is also an instance of any of the classes from which arithmetic dict inherits. So X is both an arithmetic dict and it's in fact a dict. Okay. So because X is a dict, as well as an arithmetic dict, we can do all the normal dict stuff, all the dictionary methods with X. So for example, I can update X. This just works. For example, I can add C corresponding to 3. I can update X that way. And then I can check on X. I can access elements of X using the normal dict keys, no problem. So I can do all of the normal dictionary operations that I could do with normal dictionaries. I can do them with arithmetic dictionaries as well. Now, thinking a little bit about the technicalities of object-oriented programming, we should ask ourselves a quick question. Why were we actually able to initialize an arithmetic dict with a dictionary argument, considering that we didn't tell the arithmetic class any information about how to initialize itself? So pause for a moment. Why were we able to initialize an arithmetic dict successfully with the expected result without defining the init.py method? Or sorry, init method. Init.py is different. The init method. Why did that work? So behind the scenes, we can sort of see what's going on. So if I do a.arithmetic, a equals arithmetic dict, a corresponds to 1, b corresponds to 2. So this is what we did previously. And this is the same thing as calling the init method of the arithmetic dict class with a corresponding to 1, b corresponding to 2. And the thing to remember is that because the arithmetic dict is a dict, it inherits the init method of dictionaries. So in fact, what's going on is essentially the same as if I had written this. It's the same init method. It's the same init method in both of these cases. So the arithmetic dict is using the init method of dictionaries in order to create an instance of the class, because the arithmetic dict inherits and because we haven't changed the init method. Okay, so of course, when we defined our arithmetic dict class, we didn't do anything new. We've essentially taken the dictionary class and we've given it a new name. Now, the important part is that we can define new methods that are not available to dictionaries, but that are available to arithmetic dict. So let's do this now. So what I'm going to do is I'm going to define my arithmetic dict class, dict this way, and let's give it a doc string. It's a dictionary class that supports entry-wise addition. Okay, so I'm ready to define my class now, and for now I'm only going to use one new method. Remember that what I want to do is add two dictionaries together entry-wise. So we can do that as follows. I'm going to use a magic method because I want to implement addition. So I have my magic method add. Okay, so when I do add, I'm going to add self to and another dictionary that I'll call to add. Okay, so what's going to happen when I'm done is that I'll be able to add two dictionaries using the plus sign. Okay, so let's give our method a doc string, add two arithmetic dicts entry-wise. That's what we're doing. Okay, so here's what we'll do. I'll create a new dict called new, and that'll represent the sum. I'm going to collect the keys of each dict in two variables. I'll call keys 1 for the keys of self and keys 2 for the keys of the other one. So to add keys. Okay, and then I'm going to create a set of all the keys that are present in either of these two dictionaries by using all keys equals, I'll use the union method of set objects. So keys1 dot union keys2. So this is now the set of keys in either self or to add. Okay, next. I am going to loop through all keys, and I'm going to add to the currently empty new dict. I'm going to add the sum of the entries of the sum of the values corresponding to each key in each of the two dicts I'm trying to add. So for key in all keys, new.update. So I'm going to add the following little miniature dictionary to new each time. Key corresponds to self.get key 0. Remember that what dictionary.get will do is it will return 0 in this case if the key isn't found. And then to add.get key 0, same thing there. So if the key isn't found, I'll just add a 0. Otherwise, I'll add its value in either or both of the dictionaries we're trying to add. And then finally, this is a little bit of a trick that's easy to forget. When I have done all this addition, what I have is a dictionary. It's not an arithmetic dict, but what I'd like to have is a new arithmetic dict. So what I can actually do is return an arithmetic dict from new, so that when I add two arithmetic dicts together, I'll always get a third arithmetic dict. So let's try this. Initialize my class, I can define my class okay. So now if I define x equals arithmetic dict A1, B2, for example, and then y equals arithmetic dict A1, B3, and let's say C7, just for kicks. Okay, so there's my two arithmetic dicts, and now I can add x plus y. So because I implemented a magic method, the addition sign should work if I haven't made any typos. And indeed, when I add x and y, I get A corresponds to 2, B corresponds to 5, and C corresponds to 7. So I've successfully added these two arithmetic dicts entry-wise using this new magic method add that allows me to define what should happen when I use the plus sign on two objects of this class. So I can now update my pantry. So I'm gonna just copy and paste here because I don't need to subject you to watching me type this again, but I can update my pantry. So if I take my pantry and my shopping trip, okay, so what I'm going to do is I'm going to define that my pantry, I'm going to turn it into an arithmetic dict. And I'm going to turn my shopping trip into an arithmetic dict as well. So now I've transformed these variables from regular dicts into arithmetic dicts. And then I can do things like this. Pantry plus equals shopping trip. That's the same as doing pantry equals pantry plus shopping trip. Both of these work fine. And when I run this code, either way, I'll see that my pantry has been updated with all the onions and spinach and everything else that I bought. So inheritance is a way to extend an existing class to inherit some of its properties and methods in a way that also allows us to define new properties and methods that might help us solve individual problems. So it's a way of being lazy in a smart way. It prevents us from having to reinvent the wheel every time. It lets us use code that partially solves our problem and write just the last little bit of code that gets it to completely solve our problem. So inheritance is a very powerful tool when writing object-oriented programs. Okay, in our next lecture, we will continue with another example of inheritance. Thanks.